Lesson J8, Probability and Decision Making. By the end of this lesson, you should be able to use probability to analyze decisions and strategies. Let's start with some new vocab. The expected value is the sum of each outcome's value multiplied by its probability. If you know what should happen mathematically, you make better decisions in problem situations. First thing we're going to look at is calculating expected value. If A is an event that includes different outcomes, A1, A2, A3, and so forth, and value AN is a quantitative value associated with each outcome, then the expected value of A is given by value A equals probability of A1 times value A1 plus probability of A2 times value of A2 plus probability of A3, and so on and so forth. Let's take a look at an example, calculating an expected value. Suppose you're at a carnival and are throwing darts at a board like the one at the right. There is an equally likely chance that your dart lands anywhere on the board. You receive 20 points if your dart lands in the white area, 10 points if it lands in the red area, and 5 points if it lands in the blue area. How many points can you expect to get if the areas for each region are 36 inches squared for white, 108 inches squared for red, and 432 inches squared for blue? The total area is 576 inches squared. So the value of your throw is going to equal the probability of the white area times the white points, plus the probability of the red area times the red points, plus the probability of the blue area times the blue points. So the probability of hitting the white area is 36 out of 576 times its point value, which is 20. The probability of hitting the red area is 108 over 576, and its point value, again, is 10. The probability of hitting the blue area is 432 out of 576 times its point value, which is -5. So we substitute each of these in here for the different parts. Following PEMDAS, we do our multiplication first. We end up with 1.25 plus 1.875 plus a -3.75, and then we add them together to simplify. So we can expect to get -0.625 points. So you're more likely to get negative points. Now let's look at making decisions based on expected value. On the opening drive, a football coach must decide whether to kick a field goal or to throw it or go for a touchdown. The probabilities for each choice based on his team's experience are shown on the page from his playbook at the right. A field goal will give his team 3 points. His team will get 7 if the touchdown is successful, including the kick for the additional point. Which play should he choose? So step 1, first we need to calculate the expected value for both plays. So we know that they have a 90% shot of getting a field goal, which is worth 3 points. So we take our 90%, or 0.9, times 3, and we get 2.7 points. Now looking at the touchdowns, we know there's a 35% chance of them getting a touchdown. So we take 0.35 times 7, and we get 2.45 points. We need to choose the play with the greater expected value. Clearly, 2.7 is greater than 4.5. Therefore, the coach should choose the field goal. Let's look at another example. A basketball player can either attempt a 3-point shot with a 25% probability of scoring, or pass to a teammate with a 50% probability of scoring 2 points. So first we're going to do is calculate the expected values of each. So for the 3-point shot, we know the probability is 0.25. We're going to multiply that by the point value. Three times 0.25 equals 0.75. The teammate has a 50% chance, or 0.5, of getting 2 points. So we're going to multiply those two. 0.5 times 2 is 1. So which is better? Well, clearly 1 is greater than 0.75. So the choice should be that they pass. They should pass it to their teammate who has a 50% probability of scoring the 2 points. In a carnival game, you get 5 darts to throw at the dartboard at right. For each throw, you score the number of points shown. At the end of the game, you add all your points and get $1 for each point in your total. If the number of total points is negative, you get nothing. What is the expected value for the number of points when throwing a dart, assuming your dart lands at random on the dartboard? And the last part we're going to look at is, if it costs $5 to play, do you expect to make money or lose money at the end of the game? So for the first part, we need to find our expected value. So 15 out of 16, or about 0.94. So what we do is we would find the probability of each section. The probability of it landing in the white ends up being 1/16, red 3/16, blue 5/16, or green 7/16. And then we need to add them all up. So adding them all up leads us to 5/16, and that's our expected value. Since this is less than 1, you're more likely to lose money playing this game. The expected value is 0.94. Therefore, the expected value after throwing 5 darts is about $4.70, or $4.70. So if it's costing you $5 to play this game, you're going to lose about 30 cents playing this game. Not a very good deal. I'd recommend not playing.